Welcome. Today we'll talk about the vertical structure of the ocean. And the structure of the ocean is determined by the density of seawater. And we call that by the Greek letter rho. And there are really three factors that determine rho. Rho is a function of first temperature, second salinity, that's to say how much salt there is, and thirdly the pressure, because water is not an incompressible fluid, so as you go further down in the water column, the pressure will compress the water parcel and increase its density. So we write that as rho is a function of T, S, and P. For the purpose of this course, though, we will just focus on the main components, namely temperature and salinity, T and S. As we know from the atmosphere, if a fluid is warmer, it's lighter. So in general, if you have high temperature, high T, you have low density. And the reverse is, if the water is cold, it is typically quite dense. So in general, you will have warmer water near the top and colder water near the bottom of the ocean. However, this is made more complicated by the presence of salinity. Because if you have high salinity, you also have higher density. And if you have low salinity, you have low density rho. And so depending on the salinity of your water column, these factors might be competing, temperature and salinity, in setting the density. And so we'll look at some typical profiles. For most of the ocean, the temperature is more important, is dominant in setting the density. And that is at least partially because the temperature varies quite a lot. And so the surface of the ocean often warms up a lot and is a lot warmer than at depth, and that dominates over any salinity effects. So if we draw a temperature profile, let's say we have temperature in degrees C on the horizontal, and then depth going down. So we have 0 degree depth in meters. So what does a typical profile look like? Well, that really depends where on the planet you are. So in the tropics, you have very warm temperatures near the surface all year round. So you will have a region near the surface of the water column that has temperatures above 20 degrees. And then that's just the surface layer, which sort of receives all that solar radiation. And then suddenly temperature decreases pretty rapidly and goes down to fairly close to 0 for something like below 1500 meters or so. So this is a typical temperature profile in the tropics. Now this layer here near the surface is called the surface mixed layer. And the reason why it's called mixed layer is because you have a lot of wind input here, and that leads to turbulence and mixing. And as a result, the temperature is so uniform and doesn't vary in the mixed layer. And the depth of the mixed layer varies depending where in the global ocean you are. And it's typically between 10 and 100 meters or so, this depth here. So the very top of the ocean surface. Now, in high latitudes, it's much colder in general. The atmosphere is much colder as well. And so you also have a lot of ice floating on the top of the ocean in many cases, which additionally keeps the surface cold. And so the temperature profile looks much more like something like this. High latitude temperature profile. And when we later talk about salinity, you can imagine that since the temperature barely changes, if you have changes in salinity now, that can impact the density. Now in the mid-latitudes, things vary a lot with the seasons. So here in the mid-latitudes, in the winter, you might cool down the surface to 10 degrees or so. And then that can, in the summer, can warm up this whole region up to 15 degrees, for example, depending where you are. So this is mid-latitude, and then this is winter and summer curves. So this picture gives you an idea of what the vertical structure of the temperature of the ocean looks like.